Ladies and gentlemen, welcome back to the True Life Podcast. I hope your day is beautiful. I hope the birds are singing. I hope the wind is at your back. I have with me Dr. Ewelina Kurtys from the white hot frontier where science dreams itself into reality comes today's guest. A mind forged in the crucible of neuroscience, sharpened by 20 peer reviewed papers, and reborn as an entrepreneur daring enough to translate the most complex research into living, breathing impact. Dr. Ewelina is a scientist turned founder, a bridge between the ivory tower and the marketplace, guiding technologies from the spark of an idea into engines of transformation. Through her company, Ekai, she scales the visions of science driven innovations, turning breakthroughs into revolutions. Her expertise runs from biology to biomedical science, from engineering to signal processing, and from R&D labs to boardrooms where the future is negotiated. Dr. Ewelina, thank you so much for being here today. How are you?
I'm great. Thank you very much.
Yeah, fantastic. It's such an incredible time. And I think the things you're working on are absolutely fascinating. And I can't wait to tell the audience about them.
Thank you
Maybe you
so
want
much.
to, yeah, maybe you want to give us a little background. Like, how did you get into this whole world of building computers from living neurons?
So I did PhD in neuroscience because I always dreamed about being a scientist and I always was fascinated by human brain. But after some time I left academia, I was curious what is outside in the real world. So I started to work with startups. And initially I worked on medical imaging service because that was my field also in the academia. I did a lot of research in medical imaging. So I started with that. And then I learned all the commercial part or the business development sales. I become fascinated by this, but I also learned about artificial intelligence because it's heavily used for analysis of images, medical images. And then I started to go for conferences, for meetups. I was at the time in London, which was a perfect place for this. And I realized that there is much more than medical imaging in this. In AI, and I realized how many opportunities it can bring. So I started to work on commercial applications of AI broadly, not only on medical imaging. I founded my company, Ekai, to work as a consultant, and later I started to work also with Final Spark, which is working on the future of artificial intelligence, which is biological computing, what we believe.
I can't believe we're at this section of the world where we're looking at biological computers, and sort of brings up the first question I have to mind. Like, you've lived in both the world of rigorous neuroscience and like the high risk frontier of entrepreneurship. Do you see yourself as more as a translator of science or as a midwife delivering the future?
I don't know. I think we are creating the future. We want to make the future. So that's how we see ourselves. It always takes some risk, of course, when you do something new, which nobody else did before. But we want to change the future. That's what we want to do.
Yeah, we're here. Let me bring in, I have a first, excuse me, I got a first question coming in from the audience from my friend. Who is this coming? It's coming from Amara from Cape Town. And he says,
Mhm.
Dr. Curtis, in Africa, we often say that knowledge is carried not just in the brain, but in the body, the land, the ancestors. When you build computers out of neurons, do you fear we might reduce intelligence to mere circuitry, forgetting the wisdom of wholeness?
This is nice question. So actually, people usually accusing us for the opposite, that we will make that by just using living neurons we recreate humans, which is absolutely not possible. But yes, it's true, absolutely. Like as a human being, we have intuition, we have a lot of stuff which are connected to our bodies. There are also scientific evidence for that, or at least hypothesis. But we don't want to recreate human with all these things with the body, but we just want to use these building blocks of the brain to process information. So it's very specific, isolated. So we don't want to create like another living creature. It's just living cells to very simple task, just process information.
I I think a lot
Of
of
course, we
people.
are not, we are not like a god, so we cannot make like new creatures.
It's interesting because a lot of people don't see it as tools, and I think
Mhm.
it's hard for people who may not have a background in neuroscience, or maybe they have a different philosophy about what life is or whatever. Do you guys get a lot of pushback on that? Like, wait a minute, you're creating this life over here and you're turning it into a machine. Do you get a lot of pushback like that?
Sometimes, not a lot, not a lot, but sometimes people are concerned because when they hear living neurons, they are worried that it's living. But actually, living neurons are used very widely in research, in medical research. So we just do different application, but all the techniques we use is normally used in the labs all over the world.
Why is it better? Are living neurons a better way to calculate than chips or silicon, or why for neurons?
So neurons, because they are 1 million times more energy efficient than digital, and we know that digital AI has a scalability challenge. We could say so because it's using increasing amount of energy, and actually this energy is increasing exponentially. Today we can still manage that, but we can expect that in the future it can become a problem. And there are two type of solutions potentially, either an alternative energy sources or alternative computing.
Hmm.
So we work on the second option.
What's going on inside the neuron? Like, I know that, you have in a chip, you have the different parts of the chips, you got the gates opening and stuff like that. But why is the neuron so much more efficient?
It's very complex. So that's maybe one reason. So it can have a lot of states, different states. It's much more than just digital neuron. And there are many reasons actually, because neurons process information in totally different way than silicon. So in time and space, so it matters when and at which time and where in the body, in the brain, neuron is active. That is information. The brain is also processing analog information, not only digital. There are a lot of difference. There are also much more connections, also a lot of recurrent connections, which are possible in silicon, but a little bit difficult. So there are a lot of reasons. Actually, neurons work in totally different way than digital processors.
It's so interesting. What does the computer look like? I would imagine that it would have to have a different kind of housing on there, or would have to have, like, does it have more fans? Does it have to be warmer? Like, what does the build look
Oh
like?
yes, definitely warmer. Yes, that's you're right. So actually, on our website, finalspark.com, you can see the live view from our lab. And there you can see actually how it looks from the camera. And we put little blobs of cells. They are actually it's difficult to see with your naked eye, but because this is just half millimeter diameter, a little blob in three-dimensional, and they consist of around 10,000 cells each.
Oh.
10,000 neurons, and we put them on electrodes, on 8 electrodes. So usually when you look at the picture, you see very clearly the electrodes, but not the rest. So this is how it looks. Everything is in the medium. So it's a little bit pink, I would say. Usually the medium, the liquid in which you keep cells. And then it's all in the incubator, so high, 36 Celsius degrees. And yes, all the conditions have to be as close as possible to what we have in the body. So we have to make something what is called a physiological condition. So temperature, pH, everything as close as what the neurons have in when they are in the brain.
So no
Otherwise,
laptops
it gets
anytime
stressed.
soon then.
Hmm?
So no laptops anytime soon then.
Well, actually, our competitors, Cortical Labs from Australia, they have done some prototype of a portable computer. However, we believe
Whoa.
more in the bioservers. So we want to make central, accessible remotely bioservers, the same way as today you can use cloud computing. Tomorrow you can use biocomputing.
Okay, that's blowing my mind. So you can build the computers out of neurons and they can still send information to, like, a cloud server somewhere?
Yes, yes, yes.
That's
We
so
assume
crazy.
yes. because actually everything will be interfaced with the digital computing. So actually today also in the lab, we have the heart, the bioprocessor, which is living neurons, but actually it's interfaced with the digital technology. So there will be always this hybrid system.
It seems like so much more than a computer. It seems like this kind of technology could also be used within the human condition to help solve like neural problems or body problems or disease.
Yes, you are right. There are many ways we can expect. One crazy way is that if we learn how to modify, how to teach neurons in vitro in the biocomputer, how to process information, then maybe one day we can upload, for example, a full foreign language into our heads because we learn how to teach neurons. So that's a crazy idea. But there are many things which are much, let's say, which are possible even today. So actually, what we have in the lab, our bioprocessor, could be used for drug development or to study the physiology of neurons, so to learn how to maybe cure disease. Because we have quite efficient platform, we have neurons on the electrodes. With this, you can do electrophysiology experiments. You can test also in very sensitive way, for example, toxicity of different substances, because anything happens to the neuron, you see immediately in the electrical activity. So this is could be great tool. Another idea is maybe that it could help also in the research on brain computer interface, because we also kind of like interface with neurons, but outside the brain. There are also some ideas to make kind of like implants, so that you can produce something in the lab and then put it in the brain of a human. It's not something what we try to do, but these are related fields, and what we do could help in that.
Wow. It seems like not only is it building a computer, but it's also just learning about the brain. Like when you're able to find a way to train neurons to do something, you're simultaneously figuring out how we think and how we act. And it seems like it can open up a whole lot of new doors.
Yes, absolutely. Although that's not the objective of our
Right.
project. So we don't try to understand, actually, we try to make it work. So it's very engineered approach. But you are right, of course. I think with this research, you maybe we can learn something. Although it's really, I think maybe when you have a human brain, it's much more complex also because you have body, as we said before.
Yeah.
These things also matter. I'm not sure how much we can translate this, but yes, we can maybe learn more about how neurons are working. Yes.
Are you seeing, like when you use this computer, are you seeing any sort of different modalities in the information you're getting back? It seems to me that this is a whole new way for a computer to sort of learn or to give information back. Are you seeing different information coming through the living neuron computer than you would through a traditional computer?
We would like to do the same tasks as with digital AI, but the encoding is different for sure,
Mm.
which is not fully understood yet. That's the one of the biggest problem of the project, because nobody knows actually how neurons encode information. But they do this in the different way, in form of spikes, which have frequency and the location also in the tissue. So yes, it's for sure something different, but we don't fully understand how it works.
It seems almost sci-fi to me. You know what I mean? Like just to
Mhm.
see the bridge between reality and science fiction on some level. But uh, obviously you have working computers out there. Are they like if I were to go to the site, if I were to go to Final Spark right now, would I be able
Mhm.
to try it out or see it how it works or
Yes, actually, this is very cool because our lab is available remotely to researchers from all over the world, and this happens during COVID. Happened because our researchers wanted to do research, despite the fact that they had to stay at home. So they developed the remote system, and everything in the lab is automated. So this remotely you can access, control everything. You can
wow.
stimulate neurons. You can collect data, analyze, do full experiments with never coming to our lab. And we decided to invite some universities to collaborate. We selected projects which were the most promising in our opinion. So we have now nine and maybe one more free users, universities which are using the neuro platform, we call it the lab, for free. And we also, what is really surprise for us, very nice, is we are also using, we are also having clients which pay us to use our lab. So it's also some commercial success, very little, but still.
Mm.
And it doesn't work yet, of course. You cannot process really information. It's rather, at this stage, is more fundamental research on how neurons process signals.
Unbelievable. So how long have you been working with this particular project?
Well, I think since more or less 3 years, uh, but I know the founders maybe 5 or 6 years. Time is passing very fast.
Of course. What is the most like, in your opinion, what is the most fascinating part of this research that you've seen in the last 3 years?
I think the coolest is that it's really tricky task for signal processing. You know, there's a lot of mathematics in this. Actually, it's maybe biology is just a tool. We use biological tissue, but the biggest challenge is in actually engineering and mathematics here, data analysis. So it's fascinating, and people have all crazy ideas how you can interpret the signals from neurons. So that's funny.
It is funny. It's interesting to think. I got another question coming in from my friend Ronga. And Ronga says, how should we even name these creations? Are they machines? Are they organisms? Or first citizens of a new species?
I think they are not, well, I wouldn't look at them in such a way. Um, I think people like to anthropomorphize stuff.
Yes,
So we see, you know, human
right.
traits in everything we see around ourselves. I think they are just computers, like robots we have. Of course, we also see human traits in the robots. There's a lot
Yeah.
of discussion about this, I know. But I think it's just our imagination. So
Mhm.
yes, but yeah, we also talked with philosophers actually of technology. So just in case there is any worry about consciousness, or you know whether these living computers will have some kind of, you know, I don't know, some kind of consciousness, for example. So we encourage philosophers to work on this, on
Mm.
biocomputing problems, because of course we are not competent to talk about this kind of stuff.
I think it's brilliant. It brings in a whole new world to computing when you start bringing in the philosophers. Maybe for good, maybe for bad, I don't know, but it's interesting to bring in that aspect of it. And in some level, it does humanize it. When you start bringing in the philosophers to talk about what you're building, it sort of gives it a whole new dimension on some level, don't you think? Or do you?
Yes, I think so. Yes, absolutely.
How does it revolution AI? Like, we see AI on the cutting edge right now, and there's
Mhm.
so many fields that AI is able to not only help people with. I see AI, my personal opinion for everybody listening is that AI is just a tool. It is a
Mhm.
way in which we can kind of see ourselves. It's a way for us to harness so much
Mhm.
education that has been put before us. But
Yes.
you see AI just kind of sweeping the landscape right now in almost all the modalities. How would this sort of computer change the nature of AI, or would it?
Well, the main effect will be the saving of the energy. So that's what we
Right.
believe. And we would like to match the performance of digital. So for now, we just hope to have the same. And generally, we think everything what is done on artificial neural networks could be much better, more efficiently done on living neurons, on living neural networks. So that's our assumption. So far, we just would like to match the performance of digital, which is already huge, let's say, huge objective.
I think you might have some chip makers pretty upset. Like, it's a pretty good way to get rid of all the data centers while simultaneously solving the water problem and the energy problem. You guys ever partner with some of these chip makers or get their thoughts on what you guys are building?
I think, yeah, we tried, but I think it's too early
Right.
to make them worry or concerned because it's very early stage. And many people also don't believe it's possible. So I think it's too early. Once we have some algorithm we can run, then maybe, but it would have to be actually really advanced. Uh, if we can run ChatGPT on neurons, then that would be serious maybe to consider. Otherwise, people will have doubts whether it will work, because it's also long timeline. We expect it will take us 10 years to build by a computer, assuming we will accept an investor, because we are currently seeking 50 million Swiss francs, which is around $50 million. So we assume, yes, with this money we can buy a computer in 10 years, but it's still a long time for many. So nobody is yet scared of biocomputers.
My favorite thing is when people say this will never work. On some level, to me, that is like, watch. Let me show you how it'll work. I love to get to hear people say, like all the naysayers out there and
Mhm.
stuff. Like if we were
Yeah.
to imagine in the future a little bit, like if we just went way out on the imaginary branch, how could it change education or medicine or even art?
I think, well, artists are also working with us sometimes. They try to make some art using the signals from our neurons.
Right?
So it already happens. But I think it will change the same way as digital AI, because artificial intelligence in general, it can help us to automate, it can teach us stuff. So I would say, because generally we just want to change the processor.
Right.
So at the end, we don't want to change the experience of the end user. So you use the software same way, but we just want to change the processor. So actually, all the, let's say, the results of artificial intelligence in our life of digital would be the same on the biocomputer.
Oh man, it blows my mind to think. Is that possible? That can you just change the processor without changing anything else? It seems like if you're changing the brain, like you're changing everything else,
Well, it's complicated, but at the end, we would like to be able to run the same algorithm.
right?
Uh, so yeah, so we hope it could work the same way.
Yeah, it's interesting. It may take a whole new language on some level. Like we're constantly seeing the different rails that computers are built on, changing their language, whether it's Ruby on the Rails or whatever these new languages are out there. I could see how this might give birth to a whole new computer language.
Yes, absolutely. Actually, it's necessary, and that's why it's so difficult, because we have to figure out completely new way of programming these living cells. So that's why it's challenge. And yes, we will need new ways.
Are you using AI to help you figure out these problems?
Sure.
Of
Yes,
course.
yes. It would be crazy not to do this. We use absolutely. I think it's extremely powerful, and it's very risky not to use it in any work. I think everyone should try to think how you can use your AI in your work, because if you don't do this, then you will become very uncompetitive.
Yeah, you become obsolete if you're not using
Yes.
the tools necessary to get ahead in life.
Mhm.
It's interesting from that perspective to think. What are
Yes.
what are the founders' visions for this to be? I know we've spoken a little bit about saving energy and stuff like that, but do they have usually the founders have this unique idea of what it can do. They have this big picture idea, but maybe you could talk about the founders and what their vision is.
So the founders are Fred Jordan and Martin Kutter. These are Swiss entrepreneurs. They have a PhD in signal processing, so they are more on the mathematics engineering side.
Right?
And they have already successfully built another company, Alvision, which is on digital technologies, which is profitable because it's technology which already exists. And generally, the idea, the dream was, they founded the company because they wanted to make a thinking machine, which is a dream of many engineers,
Yeah.
to make some superior artificial intelligence. And initially, they did research, fundamental research in artificial intelligence, in digital, but they realized that it costs too much. Because if you want to make better model, better AI, you just need more money. So they realized that for a small startup, they need some different approach to make a difference. And they decided to try to use living neurons because they are so extremely energy efficient. And also another reason was because one of our colleagues, actually the first employee of Final Spark, He had some experience working with Professor Markram, which is a very famous neuroscientist, also working in Switzerland. So he had some experience with living neurons. So that was good starting point to try to program living neurons. And this is actually much cheaper than building ChatGPT, for example. So at least at this stage. So yes, so that's a better strategy for a small startup with limited resources.
What about you from like a neuroscience perspective? Like what is it? Is there something that you passionately want to solve with this? I know we've talked about energy, but is there something else for you personally that you would like to see this particular mission accomplish?
No, I think it's just fascinating to crack the
Yeah,
case, how to
yeah,
interact with living neurons.
yeah.
For the moment, it's very, very difficult, sometimes random. We do a lot of automated experiments, really a lot of trial and error, and it's just fascinating to crack the case. Just to try to. It's very difficult. So I think it's. I'm very curious how it will go and what will be the algorithm for teaching neurons and processing. So to make them process meaningful information.
So many people I talk to that I admire always talk about this insatiable curiosity, this ability. Like, I wonder what it is. I wonder why that happens. What is it for you? And like, how come you got into neuroscience? Like, what was it about neuroscience that you were so curious about?
Well, I always dreamed about being a scientist. So I went to study pharmacy and biotechnology, and I went to do different scientific projects when I was master student. And someone gave me a good advice that I should think of, what is the most fascinating part of the body,
Mhm.
what is most interesting, and go there. And I did it luckily before my PhD because I did many different projects on different fields. Also microbiology, for example. I've done some gastrointestinal stuff, but later I realized actually the most interesting is brain. So let's go there. Let's go for what is the best, in my opinion. So that's why I decided to search for a PhD only in neuroscience. And I was lucky, actually. I found a project which was very interdisciplinary, which I like because I like variety.
Mhm.
So yeah, so this is how I end up in neuroscience.
It's interesting. I talk to a lot of people that are working in like PTSD or addiction, and
Mhm.
they're using now like these psychedelic drugs that help shut down like the default mode network and stuff like that. Do you have any thoughts on the maybe the future of like getting changing the default mode network and using some psychedelics in order to get through PTSD, or any thoughts on neuroscience and PTSD or traumas and stuff like that?
Oh, I don't know anything about traumas actually. But I think I personally believe psychedelics are definitely working, and
Yes.
I think it's very powerful drug, powerful solution. Let's say, although of course, you always have to put some effort in stuff. So I don't believe in things just happening. It's no magic pill still. Because in psychedelics, there is also long integration. So it's not that it will just solve all your problem with the magic. And we also get some questions about using psychedelics, of course, in our neurons. Why not? Of course, people
Yes.
do this. But we think for now it's too early. But I think they are good because they also, I think they increase the plasticity a bit and connectivity of the brain a little bit. Yeah, but there are some papers indicating that after psychedelics you have more long distance connections between neurons in the brain. So yeah, I'm sure it would be interesting, but it's definitely too early stage. For now, we play with very basic neurotransmitters, which are naturally occurring in the brain all the
Mm.
time, such as dopamine, for example. So we try to reward neurons with dopamine. So
Mm.
if they do what we wanted, we give them dopamine. If they don't get nothing.
Ah.
Uh, so, uh, so this is actually a very common mechanism in the nature, which is called feedback loop, which
Right.
happens all the time on many levels. Also, as a human or any kind of actually animal, also we interact with the environment. So we do something, we get
Yes.
feedback, and then we adjust our behavior. Hopefully, so that's how we learn. And the same we try to do with neurons, so that We stimulate them, we make them do something. If it's okay, we give them feedback. If it's not okay, we do nothing, and then we try to teach them also in such a way. So we play with chemicals, but with the dopamine mainly, and also now with serotonin.
I was just gonna say, yeah, I was like, why dopamine? Why not serotonin? Like, what is there a difference? Can you explain the difference? Like, have you tried to use serotonin and dopamine together, just serotonin and just dopamine? So, what happens when you do that with the neurons?
Oh, I cannot tell you actually in detail because I have not seen any experiment yet with serotonin. I know they was done by our team, but I haven't seen. But generally, you expect that dopamine is kind of reward, so that the effect which you see, that you should see the behavior you wanted from neurons. So that's actually the results you can see with dopamine. But it doesn't always work. But that's at least the hypothesis, yes.
So inside the neuron, maybe you can help me and my listeners. Inside the neurons, are there like synapses and dendrites? Are those inside the neurons?
Yes. So in every neurons on the surface, you have different receptors, and then depending on which receptors you have, they can be susceptible for some specific substances, which can trigger the receptor and then trigger some stuff in the cell inside. So yes, so this way it works. So different cells have different receptors, so they are sensitive for different kind of substances. And this is how the whole signaling works. And of course, not every neurons have every dopamine receptors. So yes, so there are many different type of neurons, and actually we are still trying to figure out which neurons are the best for the learning, and so that they have also all the receptors, everything what is needed to execute learning, to learn, to teach neurons something.
Is there a specific set of neurons that you guys are using specifically for the computers?
Well, we use neurons rather which are in the cortex, because that's, let's say, the thinking part. But there are still a variety, and we also think about combining them with other type of neurons. So it's very complex, a very complex problem. Our biologist Flora, she has a lot of ideas also about how to construct our organoids, which are the structures of with the neurons, and which kind of neurons combine there. So we are also experimenting on that.
Yeah, there's a lot of new cool papers out on all the neurotransmitters in the gut. Like apparently there's like a really incredible gut brain sort of bridge right there. It might be interesting
Yes.
to
Yeah, absolutely. Although this is a little bit different because that's in the living body, so you need the gut. But yes, absolutely, there is a lot of research on that. There is also a lot of inflammation now with the Western type of diet, which is very unhealthy.
totally.
This can also affect this brain gut axis. Yes, absolutely. I think a lot of things happen in the guts also, but that's not the case for biocomputers. They have only neurons there, so no guts.
It just brings up so many more questions. Like I wonder if you use neurons from the right side of the brain, if you would get more of like the big picture versus like the left side of the brain where it'd be more analytical.
I think this is too early, and I'm not sure if this is the matter of biology of neurons. Maybe it's the matter of structures which they form. So I'm not sure. No, I think it's definitely too early about that.
Yeah.
Think about
I
this.
think
Yes.
I think I should call some of my friends and we should sort of write something up for the founders to use psychedelics in there. That would be super
We
awesome.
are actually open to accept any kind of ideas. Of course, we cannot always do them in the lab,
Right.
but you're always very welcome. And anyone else who is interested, on our website finalspark.com, you can fill in the form for researchers, for investors, or for press. But also, it's very easy to contact us by LinkedIn, or also on the finalspark.com website. We have a team section, and you can find there also all the email address from our team. So it's very easy to get in touch with us.
Have you noticed anything surprising or anything sort of novel as you guys are working on this? Sometimes like these things happen. All of a sudden hey, I didn't expect that to happen. Have you noticed anything surprising or sort of novel as you've been working through this process?
I think that every research project is always surprising and full of
Yeah.
novel stuff, although there are technicalities. So
Mm.
there are a lot of little things. But yes, there's always surprise. There is always something you didn't expect. Absolutely.
What is the most surprising thing that for you,
I don't do directly the research because I do commercial part. So
right?
it's a little bit different. I don't know if it's surprising. Um, Hard to say. I would have to think about this. But for example, for technical stuff, what was surprising that we have so much noise because actually biological data are very noisy.
Hmm.
So we had to develop a system for that to filter out the real signals from the noise. So that's something maybe there are a lot of little things when you start you don't know, and then
Yeah.
you have to discover them, and you have to really understand very well the system on every fundamental details. So when we send the electrical signals, we need to exactly know what happens with these electrons, because the current is the electrons, and from the physical point of view, you have to think about this deeply, so that you can improve the system.
Yeah. It seems like it would be absolutely fascinating work to see it in action and to see the way that it computes. And let me jump over here. I got some other people chiming in the chat over here.
Oh,
Who do we
fantastic.
got? Yeah, we've got Ethan come from San Francisco. He says silicon chips gave us Silicon Valley. Neuron chips could give us something far stranger. Do you think the next great tech hub will be a laboratory, a monastery, or something in between?
No, I think what we have has nothing to do with the monastery. No, I don't think so. I think yes, well, it's possible that. But however, I think that generally because of the globalization and actually because of the AI, which is remotely
Right?
available, I wouldn't see the. I don't think there will be so much concentration in one place, because actually innovation is spreading. So I'm maybe it will be difficult to make physical place which will be central, because also the bioprocessor, the computer, which will be central, okay, available remotely, but we can build many of them in many different places. So I'm not sure it will be one place, but for now it's Switzerland,
Excuse
which is
me.
actually a very innovative place. So
Yeah,
it's a good place to make some innovation, a very vibrant community, a lot of huge density of innovative people.
yeah. Really intelligent. I can't help but see when I look at the world of science, like I see it moving in, and maybe biology has always been part of the human condition, but it seems to me like science is beginning to move closer to spirituality on some level. And I'm not saying the computer's spiritual or anything like that, but it does seem like science moving forward is getting closer to this sort of human connection. Like we're moving away from specialization into a more holistic approach. And I kind of, if I'm being honest, I can see that point of view from building a computer out of neurons. It kind of seems like we're coming together. What are your thoughts on the future of science and sort of kind of coming together as a whole?
Well, I think you could look at this different ways. When you look at digital AI, you can see it becomes more empathic,
Hmm.
actually. So, when you talk with ChatGPT, actually, many people use it also. I saw some articles for psychological advice, but it's
Yeah.
not always a good idea. Because ChatGPT has no feelings, which is but has reason, which in humans is exact trait of psychopaths. So you have logic but no feelings. So I think it's very. I think it can be dangerous sometimes to ask for advice ChatGPT when it comes to the human stuff. I think it's better to focus on science engineering, because these tools are very, these very highly analytical tools without any human traits,
Hmm.
are much better for science and engineering. And I think the same will be maybe with living neurons, because we would like to do the same, just processor for process information. So yeah, so I think we shouldn't look humans in them. But I see, unfortunately, there is such a trend, and also people sometimes make friendship with chats, with bots, and so yeah, that's something I don't like, but unfortunately, it happens. And another thing you can look at, you can wonder what is the border between science and technology, because if we use living cells to make a computer, then there is no border. Yes, where life ends and when technology starts. So maybe in this case we are blending a bit, but philosophers say that even with the smartphones which we have today, we are different. So actually, technology is part of us since a
Yeah.
long time already, and it's changing us. So we would be different people without technology, which is actually true.
Yeah.
Yeah, so in this way, it's a blending a little bit, and actually, that's the future also, which is described in books in sci-fi. Like you see cyborgs, which have, and people have a lot of ideas how to actually for implants. So actually, one day maybe our body will be fully exchanged. Yes, because we will have everything improved by the implants. So yeah, it's interesting how it's blending the dead matter with the living matter.
Yeah. Here's since we're on the topic of sci-fi, I've been reading some papers lately, maybe just more like articles to be honest, but they were
Mhm.
talking about the possibility of remembering the future. And like it's interesting to think about that aspect. First off, do you like sci-fi and what are your thoughts on being able to remember the future? Is that like mumbo jumbo or is that like
I don't
something that
know.
you think is possible?
I have no idea about what is the scientific ground for this. I have no clue. I think it's fascinating to see. I'm not sure I'm reading so much sci-fi. I did when I was a child. I
Yeah.
loved a writer which was his name is Lem. He's very famous in Poland because it's a Polish writer, but I think he also gets some traction outside Poland. So I liked his books. He was writing a lot about the future, about people going into the space. But now I think I like more to see what is real. I think,
Mm.
and I like just to see the progress in the real time. That's fascinating. I'm happy to see that today we can do much more. We can do things which we couldn't imagine like 5 years ago or 10 years ago, and I like that. I like the change and the progress, but more in real time. Actually, I don't think so much about the future because who knows. We are here today, so it's important to enjoy today. To be honest, and important, I enjoy that we can work on such a project like Final Spark, because it's cool, it's nice. But even today, it's just nice to work on such stuff, because you have so many nice discussions, about so many. It triggers the imagination, Every time I go to speak somewhere, people always ask questions. We always have a lot of questions because it's fascinating topic, so it's cool just to do this today. And yeah, who knows in the future what we can do. I'm sure will be a lot of progress in general, but I cannot predict all the consequences. Definitely not.
It is fascinating. You are the perfect person to be there because I I think so many people they go to work and they don't have imagine like sometimes you can go to a work that's just four walls and you're sitting in front of a computer like there's no
Mhm.
imagination, but when you live in an environment or when you work in an environment that's full of imagination, that sparks creativity, that sparks that
Yes,
sort of
absolutely.
beauty that makes you want to create, right? Like imagination and creativity seem to go together.
Yes, absolutely. I think so. Mhm.
Let me jump down here. I got some people stacking up. Thank you to everybody in the chat hanging out with us. Forgive my philosophical bend there. I can't help but ask the question. So, who do we
No, no,
got
it's
over
very
here?
cool. I like it. I like it.
Yeah, me too. It's super fun to think about. And that's good because the next ones coming up are going to be along that vein. This one comes from my friend Naomi Goldstein from Tel Aviv. She says, "Every new intelligence we've birthed, from language itself to artificial intelligence, has reshaped how humans see themselves. How do you think humanity's self-image will change once we share the planet with living computers?"
I think I would say the biggest change is the AI in general, and it doesn't matter if it's run on living computer or digital. I think this will change a lot. Because we already, before we were thinking that we are the only one who can do art or science. Now it's not the true, not the case. So I think this changed a lot how we think maybe about ourselves and what is human. And if we see even computers or robots behaving maybe in like human, then we can that can change a lot. like they will be maybe we don't see the difference between human and computer. So I think it's more about what is possible in software and doesn't matter on which hardware it runs. So it's more the AI in general, I think, will change a lot about how we see ourselves and also our situation in many ways. It will for sure, many jobs will disappear, and I think a lot of stuff will change.
Yeah, it's a great point. Naomi, if I was going to answer that question, I
Hmm.
think that we're in the midst of like an evolution of awareness. Like I think I think that language itself is changing, and it always does. But with the invention of AI, I think AI is sort of teaching us how to communicate more effectively. Because a lot of people do use it for friendship. A lot of people do use it to understand their own thought processes. And in doing so, they learn how to communicate better. And then they can put better communication out there for other people. But let me ask you, Evelina, as someone who speaks multiple languages, how do you think AI is transforming our language?
Well, actually, it's funny because now maybe it will not be necessary to speak other languages because there are some technologies in progress where in the real time you will be able to speak your language, your mother language, and AI will translate to the other person who, so you will speak, I don't know, in English with Chinese, and you both speak your own mother language, and AI translate this. So I think it's funny. Maybe we will not need anymore to study languages.
That would be devastating, I think. You know, the
No, I
problem for
think it's
me,
a pity. I think it's a pity because still, when you learn, I think you develop a brain also. You know, it is good training
yes.
for your brain when you speak many languages. And I think, yeah, it's not the same. But who knows? Yeah, maybe. I think it's a pity, yeah, because it's nice and it's nice to speak different languages. It gives you some kind of like a second life. When you speak another language, you kind of have like another life. This is my impression.
Yeah. Yeah, I think it's true. You get to see the world through a different lens when you use different language. Like
Yes,
in German,
absolutely.
there's all these different concepts that like
Yes.
you don't even know. In America, we don't even know these different concepts. Not everybody, but I guess
Mhm.
it's true for everybody. Depending where you are in the world, you're sort of limited to your cultural language because that's how you see and view the world. But when you
Oh,
learn
yes.
another language, it opens
Yes.
up this whole new vista for you.
Yes, that's absolutely true. Yes.
I think the new Apple iPods coming out right now, or the new Apple earbuds actually have that feature. I don't know how much they
Oh,
cost, but I think I read that or saw that
interesting.
in their
I didn't
aspect.
know that it's so fast on the market. Oh, that's great.
Yeah. But that opens up the problem of like translation equals interpretation. So when
Mhm.
it's translating something, that's someone else's interpretation of what they're saying. But maybe that's just an issue with language.
Well, it's always a challenge because when you
Yes.
translate, things are the meanings of the words are not fully overlapped, and it's, I think, normal thing, always a challenge to translate.
But maybe this takes us back to the computer conversation we were having earlier. Like,
Hmm.
isn't there another form of language? As someone who studied neuroscience, like
Hmm.
my mannerisms, the way that I move my head, like
Hmm.
a lot of people talk about the frequencies that come from your heart that sort of speak to the heart of someone else, or who knows what kind of pheromones are changing in between. That's also an aspect of language, right? What do you think?
Yeah, absolutely. And there is a lot of chemicals in the human body,
Yes.
absolutely. So that's why what we do is different than the human because we don't try to recreate the whole body. We just
Right.
use living neurons. So it's much more simple system. But yes, absolutely agree with you. Human is much more than just neurons. Absolutely. It
Yeah.
has a lot of different ways of communication.
I would be interested in seeing that. And on some level, I guess, it might be fair to say that a living neuron inside a computer would have another form of communication with the individual. Like we don't know if it can transcend through the silicone, or we don't know if that neuron can communicate to us inside something, but there's a real possibility of that, isn't there?
Mhm. Yes, absolutely.
That makes me excited for the future. Like that is an amazing way to interface.
Yes, it's very cool.
Who else do I got? I got my friend. Here comes Aiko. Aiko from Kyoto. Thanks for hanging out with us, Aiko. He says, in Zen, we sometimes ask, does a dog have Buddha nature? I'll ask you a new version. Does a neuron computer have Buddha nature? Like that's kind of what we're talking about.
No, I think no, because I believe, it is just living cells, so it's not an organism, it's not like a human. I think it will not have all the traits which human have and living organism. That's my opinion, of course. I'm not philosopher.
Is it important for the company to not
Mhm.
have that aspect of it?
No, it's just my personal opinion,
Right,
totally personal.
right.
No, actually, for us, it's important to work together. I mean, to encourage philosophers to work on that
Yeah,
because we want that they help us. That if there is anything we should do from the ethical perspective or philosophical, that we want to do this because we want that our work is accepted by society. But we are engineers and scientists, so for us, we are definitely not competent, maybe in these topics, and we just think it doesn't exist. Okay, but. So yeah, so that's why we think it's important that philosophers will take opinion.
yeah, I agree. I would, for me, I started thinking about what's the difference between connections and relationships. Like we see that
Mhm.
online, and we talked about that briefly with AI, like, or even like my LinkedIn friends. Are those my connections or are those my relationships? I wonder how the computers would be different if we just changed that one word. And if engineers, if I'm speaking to an engineer, how
Mhm.
would something be built different if you thought of it as a relationship instead of a connection?
I don't know. I think
Me neither. There.
I think engineers are more focused on the
Right.
technical stuff because at the end things have to work. So you have
Yes,
to focus.
it's
Then it
true.
is some down to earth problem. Yes.
Absolutely. All right, I got another final question coming in over here. This one says, if you succeed in building thinking machines from neurons, do you believe they should be this one? Let me switch it back. I like that one, Soraya, but I'll come back. I'll talk to you after this one over here. Let
Okay.
me let me change one over here. Who else do I got? Let me come up here to these ones. Consciousness in the unknown. Okay, imagine a world where neuron-based computers run side by side with silicon and quantum systems. How does that change everyday life?
Yes, this is exactly what I believe will happen.
Okay.
Because I think generally there will be a lot of technologies, many different hardware, optimal for different tasks, and I think this is the future. Because today we have just CPUs, GPUs, but I think there will be much more variety, which means maybe AI will be more accessible because I can imagine that digital AI can become expensive in the future.
Yeah.
Um, so I think this optimization using different hardware will help to make AI more accessible, hopefully.
Yeah. That's a great question. Thank you. What are some other questions that you wish I would have asked you?
No, I'm actually very flexible. I love
I know
to
you are.
just see what comes to mind of people. So I never have any, I don't know, expectations when it comes to questions.
Hmm. I think it's absolutely fascinating, and I'm enjoying our conversation a lot. Oh, here comes my friend. Here comes my friend from Norway. Polar Knights, how are you? Thank you for being here. We are
Mhm.
talking about building computers from living neurons, Polar Knights. Do you, my friend, have any questions for my incredible guest, Dr. Ewelina over here? He'll let me know in a minute. He's a really cool guy, and thank you for being here. So stoked to have all these people coming in from all different parts of the world. I
Cool.
think it's
Yes.
definitely
Lovely.
hitting on an edge over here.
This is so cool.
Yeah, it's a good time to hang out and see. What do you think are the is there a difference in your opinion between the engineers in Switzerland and in different parts of the country?
No, I think there is difference in maybe in people in general, not on
Right,
necessarily engineers, because every country has some specific culture,
right.
which I think definitely makes a difference as a whole. So, like when you look at the individual people, especially in science, I would say in engineering, they are very similar actually. So
Right.
that's why usually when you do research in academia, you have mix up people from different countries, but they very similar because I think maybe just training in science make us similar to each other. But when you look at as a whole at the society, then I think there are huge differences. But only as a whole, at the individual, if you compare, then I think it's a bit. At least in science, in engineering, it's not so much different.
I agree.
But huge culture difference, yes, as a whole, the society.
My friend Polar Knight says, I never question people that are smarter than me. I just listen and learn.
Oh, so
Thank
nice.
you, Polar. That's awesome to hear. Um, what else are you working on? Do you have other projects? I know that you have your own individual website and that you also are a giant part of Final Spark, but what are some other projects that you're working on?
Well, I'm currently fascinated and thinking about neuromorphic computing, which is cool because I'm generally interested in brain inspired computing. And neuromorphic is something in between, let's say, between biocomputing and digital. Because neuromorphic computing is where you try to use some principles from human brain to make computation more efficient. And you can do this by improving software, or also you can do new chips which are digital, or even try to make analog chips like your brain. So that's I think cool, and that's a bit short term because I think biocomputers will take us 10 years to build, but neuromorphic is something, let's say, with the short term objectives. So that's quite interesting. So that's one thing which is interesting for me now.
Nice. And it almost seems like the evolution of the biocomputers is the neuromorphic. You probably learn a lot from that aspect of neuromorphic that you could put into the biocomputer.
No, actually, I think that
No?
is first neuromorphic and after
Ah,
is bio. But
oh, that's
maybe, who knows? But
yes.
actually, there are some researchers who wanted to do, like you said, some neuromorphic people come to us to maybe test stuff on neurons. Yes, you're right. I think it
Ah,
can be in both sides.
yeah. It's amazing to think about the what an incredible time we're in right now to see technology where it is and to get to be part of it. And especially for you, get to play such a unique hand in this new evolution of computing.
Yes, it's cool. It's very nice. I love that.
What are some of the conferences that you've been to that you talk about this kind of stuff?
I was I come back this week from Katowice, which is in Poland,
Hmm.
where I presented. Um, and I was also in London. I was in Warsaw, in Poland. So yeah, we are going. We are very open to visit conferences if we are invited. Of course, we have limited resources, so we only can come if we are invited to speak. But yes, it's also cool. Always nice, and I think what I really like is there is always a big engagement. So after the speech, I always get a lot of questions, and this is cool. I like it because I think this project triggers imagination of people, and I like that.
Yeah, me too. And I think we need it now more than ever. It's interesting to see. In the time of crisis, there's great opportunities. And I think that that's what
Yes,
we're kind of seeing evolve over here. Doc-
absolutely.
It's super awesome. Dr. Evelina, I'm so stoked to talk to you today, and I look forward to some future conversations and learning more, and maybe speaking with the founders, and definitely putting together someone out there, some people that I know, to submit
Mhm.
some ideas about psychedelics and these kind of computers. So,
Thank you so
um,
much. I would be. We are very open to listen to any ideas. So very happy.
nice. Okay, say people are listening right now and they want to get a hold of you, or they want to reach out to you, or they want to invite you to a conference. Where's the best place for them to find you and reach out to you?
So LinkedIn is great place to reach out. I think it's very easy to find us on LinkedIn, and we always answer. So I think it's the easiest.
Okay. Ladies and gentlemen, Dr. Evelina, hang out with me for just a second afterwards, but to everybody else within the sound of my voice, I hope your day is beautiful. Go down to the show notes, check out Dr. Evelina, reach out to her on LinkedIn. I'll put all those links in the show notes down there. And that's all we got for today, ladies and gentlemen. Have a beautiful day. Aloha.
Aloha.